Well, welcome back for those of you who are back, and those of you online, again, thank you for staying on. And we'll go ahead and get started with our session 3. My name is Rusyn. I'm a member of this committee, and I'll be moderating session 3. And session 3 is really going to be on the practical examples and the type of science that may go into, to fill in some of that vision that we had an opportunity to hear about in the sessions this morning. And I just wanted to start everyone with a couple of quick remarks and bring everyone back to where Lauren and others have started, pointing out that the advice from the national academies has been rapidly accelerating, especially from the toxicity testing in the 21st century and up to the last year's report on sustainability in the EPA. And Ayla already mentioned that some of these ideas about accelerating the practice of risk assessment really has tremendous applications to the green chemistry and sustainability challenges that are that EPA is faced with. And we already heard that it's not just the vision, but it's also the implementation. And Dan and others have been really vocal and not only spreading the word about toxicity testing in the 21st century, but actually, trying to put that into practical examples of the types of data and assays that can be applied into the traditional paradigm. And again, Ayla already mentioned the Next Gen project and the Tox21 that is actually collecting data. And I was really glad that we have this opportunity to transition from the vision and where we need to be versus what are some of the already existing ideas about how to do risk assessment using non-traditional data types. And I just wanted to use two examples from recent publications, one from a collection of authors. Kenny Crump is the first author for this one, trying to compare and contrast traditional in vivo database risk assessment with maybe risk assessment process that may not be as dependent on human or animal in vivo data. And this group of authors have suggested that we really may not need to rethink the entire paradigm. However, they pointed out a number of challenges that one needs to start thinking about if one is relying on in vitro or high-throughput screening data to make decisions. And again, the decisions at the end are still a number. So that's another limitation that has been pointed out by a number of people. And then the work from the National Center for Computational Toxicology that was published in some of this I'll come to on the next slide. Last year, the CRT journal on the high-throughput risk assessment paradigm, where again, we start collecting data and then integrating that into some sort of pathway-based information, and then think about converting in vitro dose to the in vitro concentration to in vivo dose, and then incorporating a variety of uncertainty and population variability estimates and calculating some sort of, again, a number that can be used by risk management as estimated health protective exposure limit. Well, this particular paper by Richard Judson and his colleagues at the CompTox Center really laid out very nicely using data that's already being collected, and here, about a dozen or so conazole chemicals that have gone through the first round of testing in ToxCast phase 1, and they were trying to, again, put this into the context of data that is now being used, such as lowest effect and no effect level from animal studies, and then, again, there are lots of different in vitro assays, and they're trying to integrate this information into some sort of a distribution of concentrations that may be perceived as the point of departure, and then trying to compare that to, no observed effect level divided by, a factor of 100 versus where the exposure estimate is, and trying to understand whether this, in vitro data as compared to the in vivo data or exposure estimates really gives us some confidence as to where we would be should we use in vitro data results only. And again, there are a lot of really interesting practical suggestions in this particular paper. So going back to kind of setting the stage for this particular session, I wanted to again touch on the different tools in the risk assessor's toolbox, what decisions are made at what levels, that is driven both by the data packages but also by the importance of the particular chemical. And if we look at the tools that are now being used by the National Center for Environmental Assessment, the integrated science assessments are really probably the diamond package that, a chemical or a group of chemicals can get, and those rely heavily on human studies. But, the integrated information system, IRIS, and, the PPR-TV, those rely not only on human data, but on animal and traditional studies, but also begin to start incorporating in vitro and alternative species information. And then finally, all of the high throughput risk assessment is likely to have very little animal data and maybe even less human data other than exposure. But then what about the tens of thousands of chemicals that risk assessors eventually will have to consider? And again, Dr. Knight has given us a good overview of the challenges that are faced by ECHA in Europe with having to do some sort of assessment on all chemicals, not just on those chemicals on which we have the data. And really, systems biology data, this is what this session is going to be all about, is applicable not only on this end, but I think, as Dr. Cody already pointed out, some of the heavy or data-rich chemicals also may benefit from systems biology data for us to use them as test cases. Well, if we look at basic components of an assessment, again, there are these 4 steps, but it was already brought up that, ranking and prioritization of chemicals, not just simply for, whether or not they will be used or not, but also how to decide which chemicals need to get into higher tiers of assessments, also may rely on systems biology data. And again, there are different types of information that potentially are applicable. And in this particular session, we wanted to really, go through some of these examples and consider them. And last but not least, it's important to remember that the end user's perspective is very important. Those stakeholders really need to be engaged early on, and this was, mentioned in almost every presentation this morning. It's really not good to build something, build these tools and get the data unless you really understand that the risk assessors are going to use it or be interested in that. So I wanted to point out to you the report that wasn't very, that isn't very long, but it's very recent on the risk assessment colloquium that just recently came out. And 3 bullets that I wanted to bring from that are the perspectives of the practitioners or end users, what they think are some of the most important things that may come out of the systems biology or omics type data and risk assessment. It's, risks for chemicals that don't have any toxicity values. So again, to go over that hump of no data, no hazard, no risk. Second is, expanding the range of endpoints for which dose response assessments could be used to calculate economic benefits. And this is really, can we go again from a number to a slope? And then finally, how can we use the power of molecular biology and the screening that one can do now to start considering not just a single chemical or stressor-based assessments, but, multiple exposures and co-exposures as well. So we've challenged the speakers to, consider a number of questions as they will go through the presentation. We'll try to keep these questions as we go through the question and answer period as well, to really try to, again, use this opportunity to highlight some of the success stories and practical applications and try to move beyond the concepts into the actual nitty-gritty and try to excite the end users about the opportunities that are presented to us. The speaker biographical information is provided in the agenda, so I'm not going to take too much time introducing them. I just wanted to say that we asked the speakers to limit their presentation to maybe 30-35 minutes, and then we try to have maybe 15 or 20 minutes for question and answers, and we will go to the web questions as we did this morning, and in addition we will take questions from the audience as well. And I just wanted to invite Dr. Chihei Young to kick it off with the QSAR approaches.